Good evening, everybody, and welcome to this evening's webinar from the IET Sussex Network. I'm Greg Hobbs, and I'm your convener for this evening. And tonight's talk is about the application of digital tools and techniques to help delivery of design and build projects in the water treatment industry. I think now it gives me great pleasure to introduce Neil Cuthbert. Neil has 30 years experience in the water treatment industry. He started out as an electrical engineering apprentice and has since worked in a number of roles: engineering, project management, senior management. For example, Neil was the MEICA project leader on the £135 million project to deliver the Beckton Sewerage Treatment Plant extension for Thames Water. And for those of you who didn't know it, apparently the Beckton Sewerage Treatment Plant is one of the largest in the country. Neil is now the Regional Engineering Manager for MWH Treatment. And so I would now like to pass the screen over to Neil to deliver tonight. And then after the talk, I will come back online, read out your questions, and we'll go through the Q&A. So with that, Neil, I would like to hand over to you, stop sharing my screen, and hand over to you.
Thank you very much, Greg, and welcome everyone this evening, and thank you for joining this evening's talk. So I'm just going to share my screen and bring up this evening's presentation. What I will do, though, I'm going to turn my camera off, because when we tested earlier, there was some audio quality. So let me just stop my video. Hopefully you can still hear me, okay, and you can see the screen with the presentation. So can you hear me, Greg?
I can, but I need to unmute before I can tell you.
Great. Okay, let's make a start. So, as Greg mentioned, I work for MWH Treatment. So we're a leading solution provider in the UK water industry, and we operate across 6 major frameworks in the UK, from right across the country, from Scottish Water, United Utilities, Severn Trent, Anglian, Thames, and Southern Water. So the treatment business has roots that go back as far as 200 years in the water industry, hence the 200 logo you can see on the screen there. And as a business, we're constantly pushing innovation and collaboration boundaries in the water sector. And in fact, we've won several awards for the digital strategy that I'll be talking you through shortly. So I currently work in our Southern Water framework in a joint venture with Costain called CMDP. So that's Costain MWH delivery partner, where I head up the engineering function. And our framework with Southern Water is to provide upgrades to both clean water and wastewater sites to meet new regulatory drivers, to accommodate population growth and general capital maintenance works across their assets. So what are we going to cover this evening? Well, as Greg introduced earlier, it's an introduction on the application of digital tools and the techniques used in the delivery of water and wastewater treatment design and build projects. So, and that covers from the concept stage right the way through solution development, detail design, and construction and commissioning. But before I take you through the actual content of the following slides, just a point around the 5-year AMP cycle that we have in the water industry. So for those of you that are not familiar with water sector, so our frameworks, they typically align to what's called asset maintenance plan periods, AMP periods, which are linked to price reviews used by the Water Services Regulatory Authority, Ofwat. Now, these AMP periods, they run in 5-year durations, and we're currently in what's called AMP 7, which commenced in April 2020. Now, the reason I've referred to these AMP periods is that over the past 10 years, it's quite a useful reference point in time to reflect on the progress of digital delivery that we've seen in the water sector. So if I go back to AMP 5, the period 2010 to 15, we saw the introduction of 3D modelling in our CAD drawings. Some initial field management devices we started to see, for example, tablets out in the field capturing defects and snagging. We even saw the introduction of some initial digital project initiation, which I shall show you some examples of later. But it was very much introductory at that stage. The AMP period that we've just come out of in AMP 6, which was 2015 to 20, we saw a significant progression in the development of tools and techniques, and more importantly, a more strategic and structured approach on how we applied those tools. Now, as we're in AMP 7 now, we are really on track to see much wider use of these tools. And I'm sure we will see many of them being embedded as business as usual throughout our projects. So the slides I'm going to take you through, firstly, what is digital delivery? A basic understanding of the terminology and how it applies to the project life cycle. Why adopt the digital delivery approach? What are the benefits? What's in it for us? Why do we do it? I'm just going to touch on digital delivery and BIM and how, in my view, the two interrelate with one another. The core of this presentation this evening is the digital toolbox. So that's where I'll take you through all the individual applications, tools and techniques that we use on our projects. And then at the end, we've got a case study, a video, where it's a really good video actually that takes you through a project where we've applied all these tools, and you can see firsthand the benefits that they brought to that project. We'll summarise on the benefits, and then I'll answer questions at the end, along with Greg in the Q&A session. What I would say is this presentation is very much an introductory presentation. I'm not going to take you through in detail all the different types of software, the file types, the applications, etc. It's more of a storyboard, a journey of how all the different digital delivery techniques interrelate with one another. So first of all, what is digital delivery? So quite simply, it's the process of integrating digital technology into all the phases of the project delivery model. So if we look at a typical project life cycle, so at the concept stage, where we've identified our project need. Now on a water project, typically that would be the identification of a new water quality regulatory driver that you've got to meet. We then move into the definition stage where we actually work up potential solutions. Now, part of that stage, we look at the actual potential root cause analysis. So why can't that treatment works meet that regulatory driver at that stage already? So we look into that, look at the options and the best value options before we move on to the design, where we actually take that solution and work it through into the who, how and what. So how we're going to develop that design, who's it going to be developed by, what supply chain integrations, and how we're going to do it, more importantly. Because a real key part of the water treatment sector is when we're delivering a project, it's not like a new build, it's not like a commercial building where we start and finish. We're often adding to, modifying and extending an existing operational asset. So it's really important that we understand how the project's going to be built and commissioned, such that we do not interrupt the supply of that site, whether it's supply of clean drinking water or whether it's treatment of a sewage process. And then, of course, at the end, we've got handover and closeout of any you'd see on any scheme. So the four main areas that the project lifecycle drop into are digital initiation, which is obviously at the front end of the scheme, where it's very much about data gathering and surveying and providing information for sharing with the team during those early stages. Before we move on to the digital engineering side, where we develop the solution, now there's quite a few tools that we use here, and as I say, I'll take you through those shortly. The digital assembly is effectively the build and commission, so it's what we are doing on site, how we start integrating that project, the new asset that we're building into the existing site, and of course the digital operation when we've handed over the asset to the client and the end user. So fundamentally, it's changing how we deliver our projects through visualization, data, and analytics. So the basic questions really, and so why do we do this? Why do we adopt a digital approach? So a key one here is communication. By digitally reviewing and surveying our sites and having that information to hand, it massively increases communication. A picture paints a thousand words. So, you know, when you look at traditional old 2D type drawings and you compare it with a 3D model, it's completely different. The level of communication that you see there visually is immense. This is a huge one for me. So it's the collaboration piece. The fact that we've got the survey information, we've got the models, they're often on cloud-based systems. It's the collaboration piece where we can all come together, the project team, from the designers, the site teams, the end users, the clients, etc., to see the solution develop. Driving innovation. So one of the techniques that we'll cover later, I think is a fantastic example of this, where the digital approach really does facilitate building your project off-site. So not actually building traditionally on-site, but having much of the project manufactured in a factory environment, safe environment, and coming together on the site. So some of the tools we'll look at later, where we link the 3D model to the program, provide that visibility, it hugely assists with delivering program and cost certainty, because you know what's coming, because you can see it, you can rehearse what the project's going to do before you've built it. Improving quality. So clash detection, just along with the 3D approach, getting it right first time is a key aspect of digital delivery. But it's listed last here, but this is really important. It's the health, safety and well-being for all those involved in a project. Some of the examples I've seen throughout my career is where we've used these tools and we've been able to work out safe sequences of work during the construction phase by minimising risk, by doing things differently, because we can visually see what's happening before it's built, right the way through to the end users, so the operators on the site that have to live with that plant on a day-to-day basis, being able to review and comment and visualise what that plant's going to look like at an early stage, to say, I can't get to that piece of equipment to maintain it. So there's huge benefits with the whole digital approach. So I'm just going to touch on now digital delivery and BIM, because they are hugely interrelated. So, as most of you on the call will be aware, BIM is building information modelling is the original term, but more increasingly now we hear the term better information management. So it's not just a 3D model, it's not just a piece of software, it encompasses the whole information management on a project. So it includes the people, processes, and technology. So it's based on a British standard. Again, as most of you, well, a lot of you on the call will be aware, ISO 19650. And the definition of that is its use of shared digital representation of a built asset to facilitate design, construction, operation, process to form a reliable basis to be able to make decisions. So on the right here, this is a model that's widely used with BIM, and it shows the maturity levels of where we are. So on the left-hand side there, very basic early doors. If I go way back in the AMP cycles, we were doing CAD initially. This was even drawing board days, really. As we move forward into the digital era, we were doing 2D drawings digitally and even 3D. But that was very much what was called level 1, and it was all about digital engineering. It didn't extend past the drawing office. It was all done within that environment, and that's where we've seen the shift from earlier AMPs into AMP 6 and certainly into AMP 7. So and level 2 is kind of where we are at the moment, I would say, as a sector. So it's where we've taken that digital engineering phase into the delivery phase, where we've moved into a far more integrated approach, 4D, 5D. So we're looking at linking the designs into the construction program and even the estimating. So pretty much where the water authorities are in the UK is, if they're not at level 2, they're probably nearly at level 2. And that's where digital delivery, pretty much some of the tools that I'll take you through really do reside, and you can see where how they support the whole better information management. So level 3, so this very much is taking the whole digital approach we see through project delivery, but it's the end user driven piece of the jigsaw. So this is where the end users are using intelligently the information that we provide throughout the project life cycle. And an example would be where we've got full life cycle management of that asset. You've got a digital twin of the asset. You've got all the information associated with it, even down to operating parameters, sitting virtually in a cloud, so you can actually operate and fully understand your asset. But that's where we're heading in the future. So just a couple of points on BIM level 2. So if you're BIM level 2 compliant, there's a few here that I'll just list. This is effectively what it means for you. So it's easier to find information. You've got one version of the truth. You've got automated workflow processes and procedures. So the systems that you use automate the review, check and approve process, and also track where you are with it. So everybody knows where you are at one time. You've got information that's cloud-based. You've got common data environments, which, I mean, at the moment, in particular, with us all working remotely due to COVID, it's been a huge facilitator for remote working. One naming convention, this is a big one for me, where how many times have you gone into a shared drive and tried to find something and everybody's named a similar document different and you just can't find it? So obviously BIM, one of the key aspects of it is ensuring that everybody adopts one naming convention so we can find information. And you've got one version of, one control version as well. So you know exactly where you are with the versions, and there's no errors moving to site, building to an incorrect version. So that's hopefully my summary of how BIM and digital deliver all fit together. So now on to the digital toolbox. So I mentioned earlier, there's 4 main stages here of the project, and we've grouped the tools into pretty much to align with those 4 stages. So you've got the digital initiation stage, where you set your initial strategy, your surveying, your visualization, the engineering, where we have a lot of the clever tools that we'll come to, digital delivery, how we use the digital aspects to integrate on site, and finally the operation and handover. So what I'm going to do, I'm going to take you through each of these 4 areas, and within each area I've got a slide showing a typical application that we use. So first off, the digital strategy. So this is not actually a piece of software or a tool, it's just a procedure, it's a method. So we found that, you know, this is absolutely key. Setting your digital delivery strategy aligns the functions in your teams, as engineering, commercial, procurement and delivery teams, so that everybody's working towards a common goal, common approach on the project. So it sets your stall out before you start. So you look at the type of project, the complexity of it, the size, and you start looking at which tools you're going to use on the project, because you don't need to use every tool on every project. You only want to use them where they're going to add value. So even on some simple low value schemes, there are applications and tools that I'll show you later that are really essential. But some of the more complex tools you wouldn't necessarily need. So by setting the strategy out at the beginning as well, it brings everybody on board and your key supply chain partners at an early stage, which really sort of maximises the opportunity and minimises the risk. By bringing those guys in early, you minimise the rework that often you'd find on an older traditional approach to a project, where you might have a design consultant produce a design, it gets issued to a supply chain, and they look at it and say, I wouldn't have done it like that. Why don't we do it like this? So it just facilitates bringing those guys in earlier. And then when you've got an agreed strategy, it's recorded in your BIM execution plan. Now, on the left-hand side there, you can see an extract from what we've called a digital standard in the JV where I work, in CMDP. So because we've got multiple schemes in our framework, it's a £300 million framework, and some of the schemes are relatively low value. So rather than have loads of strategies, we've got a baseline standard to say, right, for this type of scheme, we were going to run with these tools as default, no question. This is what we're going to have as our standard. But then we do then review if there are any areas where we might want to supplement that strategy with some of the other tools. But I can't stress the importance really of setting your stall out early on. So the first proper tool out the box is digital surveying. So this really is key. So digital surveying, there's various technologies for this, and it can be as basic as just a digital photo, 360 cameras, videos, photogrammetry. The example that I've shown here is one that we use widely now. It's our default position, and it's laser scanning. You can see the actual device on the left-hand side there, set up, undertaking a scan on the site. So, I mean, the tripod there, you can get some really great high-level views. You know, another one to tick the box of safety. If you look in the left-hand corner there, that's actually doing a detailed survey scan of a chamber without anybody needing to go in there. So really good stuff. Now, the output from the laser scan is shown on the right-hand side there. So that is actually an image from the scan. I know it looks like a photo, but that's the level of granularity when you set up and you know what you need to scan. So all those spheres that you can see there, they're the positions that we've set the scanner up. Now we wouldn't take that many scans if we were just trying to get an appreciation of an area, of a field, of a car park. But where we're doing detailed engineering integration and it needs to be millimeter perfect, we go to this level of scanning. So the benefit of laser scanning is that it produces an output called a point cloud file. And as I say, if you scan to the correct level of accuracy, it's millimeter perfect to take forward into your design and base all your designs on. But it doesn't have to be as complex as that. So, for example, 360 cameras early on in a project. If you go into a site, you don't know whether you might even be building anything on there. Quick and simple, very cheap. The person going to do the site visit can just take a 360 camera view and bring those photos back for sharing with the team. So yeah, digital initiation, surveying, key part of digital delivery. So then taking those scans and working them up into visualization. So on the top right hand corner there, you can see an image of the site. The sort of grainy image is actually an output from the laser scan. And that's been used to help develop a solution and to visualize what that potential, I mean, in this case, it was a treatment process added onto sewage treatment works. And it enables you to drop on the blocks of 3D models. So at the early stage, instead of trying to work with 2D drawings and markups, and straight away you've got an appreciation of what that plant's going to look like. How are you going to access it? How user friendly it's going to be for the operator, and it just engages the team. The one in the bottom right hand corner, it's actually the same site, but this is an example where we had a really useful example where the plant that you see on the left hand side, we had to deliver through a really tight village with very narrow lanes, and the residents were really concerned. They were concerned about damage to their property, to their vehicles. So the team put together a short video with an auto track showing the size of the actual unit, the route we were taking, and what we had to take out the road along the route to facilitate safe delivery of the kit. That was actually shown to the local residents at a village hall meeting, and what started off as a really frosty meeting just was completely calmed, because they could see we'd thought about it, we'd planned it, and they could visualize that what was going to happen. So that was a great example. The next example I'm going to take you through for visualization is a different aspect of it. So this is this particular one here was a scheme that was done for a client where we had to demonstrate to the DWI, Drinking Water Directorate, a solution that we were looking at on a particular site. And the solution, we had to demonstrate that it had been developed sufficiently. And this particular video that I'm going to play now, it shows what this was actually, the design was developed and the visualization produced as an output within a 3-week period. So let me just play the video. Okay, so so that visualization was produced by a company called Blue Sky. It's a service that they provide aerial data of existing sites using photogrammetry, and they obviously take that data. You then import your 3D model and provide that to them, and they do like a visual drape across the whole image to provide that. But I think you'll agree with me, it's a fantastic way of trying to demonstrate and visualize what's going to be built. It really helps with planning as well on large schemes. So on to digital engineering, and we'll take a look at some of the tools that we use there. So goes without doubt, I mean, 3D modeling is business as usual now. What you can see on the left there is one of the tools that we use, BIM 360 Glue, to share the model during its development with team members. Even when the project's on site, it's really useful for feeding back real-time information and comments to the designers and the CAD engineers. Now, on the right-hand side, we still, in all cases at the moment, we do then take cuts from the model and we provide GAs and sections in 2D. The reason for that is that the level of detail that's shown on the 2D there, from the additional comments and the dimensions, you still need that during the construction phases. We have had some projects that are built totally 3D, but that's certainly not business as usual at the moment, I'd say. Just a thing to note, on the right, you can see a QR code. So that QR code, really useful. So what we can add to the drawings is this QR code. Now, if we was doing okay for time, I'd ask you to try this, but effectively, when we share the video, the presentation later, if you hover your phone over the QR code, put it on camera, it'll pop up with a message taking you to a website, an Autodesk website. You click on that and you enable it, and by holding your phone upright, you can actually see a 3D image and rotate as if you were standing in that spot. So you can actually see the model, even though you're looking at a 2D drawing, the point that the QR code points to on the drawing, you're standing in that location and you can rotate 360 degrees and see, and up and down, and see where you are. So what that does, it helps in that transition where we're trying to get digital out on site, and for guys that are not used to working with 3D. So really useful tool for visualization. So collaborative reviews, again, not a tool, but a technique. And this, a couple of examples there of workshops that we've held and with the ability to visualize what we're doing, it just brings the whole team together. So we can look at potential issues, potential problems, and we absolutely have uncovered some potential costly issues on our projects by undertaking these collaborative reviews at an early stage. So another tool, I'm just going to play this in the background, is virtual reality and augmented reality. So this is a 3D model produced on one of our sites at Minworth. And as virtual reality, I'm sure you all know, it just enables you to fully immerse yourself in the actual design. So I've paused the video there for the reason that on this particular one, when the operator was walking on that gantry virtually before the asset was built, he looked over the edge and he was really concerned at the height and the level of the handrail, and he just generally felt uncomfortable with it. And what we was able to do at that early stage, before it was even built, was just to increase the handrail height from the standard 950 to stuck another, I think it was a 500 mil on the top. So it felt more like an enclosure when he was working at walking the walkway. And of course, that was all done in the safe environment of the factory before it was built. Augmented reality is where we take the 3D model, and if we're integrating with an existing asset, and you can see here a pipe gallery, we obviously need to run additional pipes there, you can actually view the new design before it's even installed, and you can look at things like access to valve heights. Are any of your routes blocked? Which, okay, arguably you would have been able to do that on a 2D drawing, but you just wouldn't have been able to visualize it as much. So this is a tool we use. As I say, it's not for every project. You know, if you've got a particularly complex one or you're integrating with an existing asset, really useful tool. So I mentioned at the beginning of the presentation, DFMA. So DFMA stands for model design for manufacture and assembly. So it's a model-based digital engineering approach, and essentially it's building stuff off-site, bringing those assemblies onto site in the largest chunks possible to minimise the amount of site time you've got, because work on site is historically, it's factually far more dangerous than working in a controlled factory environment. So we do this for concrete structures where we use precast, but also for mechanical and electrical installations where we try and bring things in modular to minimise time on site. The example that you can see here is some rapid gravity filters. In fact, two projects. The Williamsgate project was built traditionally with RC reinforced concrete structures on site and shutters. The project on the right was is copper mills, and that was installed using an off-site approach. So if you just look on the two tables there, the number of days on site, you can see the difference there. So that is a direct reduction in risk for that site, and obviously cost as well. So DFMA absolutely links into digital engineering and plays a key part. So this tool is something that we've recently introduced in some of our areas, and it's digital verification. So if you're looking to compare an as-built asset to the original design at the end of the job, typically you'd send an engineer out there, or you would have done with a red pen and a drawing, and he would have measured and marked up, sent that information back to the CAD engineer. He would have looked at it and said, oh, you've missed this, I don't quite understand that, sent it back, and you would have had an iteration process trying to communicate that that as-built information. So by doing a laser scan after the installation, comparing it to the original, there's a piece of software that is available now to actually compare the two. So that image on the left-hand side there, the CAD engineer straight away can see what the difference is and amend the model according to as-built. So digital delivery during the assembly and commission stage. So if you remember back onto the BIM wedge, this is the shift now out of that engineering space right across the project life cycle. I'll just play this here. So so program visualization, quite simply, is where we link the 3D model to the construction program. So we use a Primavera P6 as a construction program. There's a piece of software called 4D Synchro that joins the two together. And what you can see here on the left is it's not in detail. This is for a high level overview of the construction program against a date. And what you can see is the key sequencing of the project as the installation is developed, which obviously helps with communication. The interesting thing for me on this particular one was when the CAD engineer sat with the project planner and they linked the two together, the planner said, that's not right, that shouldn't happen like that, thinking that there was something wrong with the model, and it was actually the P6 program that was wrong, and there was just one small sequence that he hadn't been able to visualize across the multiple pages of the schedule, and straight away that was corrected. So the other part of so I say using digital rehearsals is this not necessarily linked to time. This is where we look at a specific task that we want to communicate or test or try. So it's a digital representation of an activity. This particular one here was a site, a solution that we was looking at a site actually, where we was looking to reuse the existing structure, and we had to retrofit the blue pipework and pumps. We would never have designed it like this if it had been a greenfield site. And as a consequence, there was limitations on access. And the client, when we took the design along to what we call an asset lifting maintenance review, they said, we're not comfortable with lifting these huge heavy pumps out the building. We can't see how you can do it safely. So the guys took the 3D model, produced this rehearsal. It's just a very short clip to show how the pumps are lifted out of what we call the wet well, how they're put onto the gantry at the top. But the key part was, how do we get that pump out the building and safely onto a vehicle, because we haven't got the height. So the guys were able to demonstrate using the trolley arrangement that came with the pump, how it's top and tailed using the two cranes, and how we ultimately lift that safely onto the vehicle. So relatively simple, quick, cheap way of demonstrating how to do a task. So also in the field, we use digital for digital field management. So we have iPads, tablets in the field, which we use to view the model. I showed you earlier how we link that model back to design in real time and provide comments. We undertake inspection and test plans. So forms that typically would have been produced in paper, handwritten, and then taken back to the office, put in a file, and that file scanned at the end of the job, goes straight onto the system electronically, and that includes permits as well. And we record defects, and the defects tool is really good because obviously you can take pictures and attach photos of the defect, so you haven't got a one-liner with someone trying to work out what that defect means. But another key part is by having the device on site is electronic diaries, and these really benefit the project team, because they're just an easy tool to record conditions on site, the weather, the attendance, who's on site, what subcontractors. A real key one is any impacts on the site to the project that have happened that day. Now that might be a weather event, it could be anything, but it's just an easy way of recording what's happened that day that's more reliable than the old paper diaries that the site manager used to fill out, that sometimes, well, they either went missing or they weren't necessarily readily available for everybody to view. So this puts that real-time data out there for everyone to see. So lastly then, digital operation. So at the end of the job, we produced all this digital information, and it's readily available to be handed over to our clients for that particular asset. Now, this is where it depends how the client how well progressed the client systems are, because if they're able to take this information and it's readily accessible to their operational staff, then they've got all the manuals that are available on a tablet at the point of application. So if they're doing maintenance on a particular piece of equipment, whether it be a pump or a valve, they can actually scan the QR code on it and bring up the actual real-time data and even videos of how to do a particular piece of maintenance. So this is something that certainly in AMP7, I think we will see a lot of development with. Okay, so that's taking you through the toolbox. I'm now going to just show a brief video of how all those tools fit together and the benefit they can bring. So this particular project it's Frankley water treatment works in the Severn Trent region. It's an old 100-year-old treatment process that's been developed and added to and enhanced over the years for various to ensure water quality standards are met. And this particular project was to replace an existing lime plant with a new lime water batching process, which assists with the quality of the water, softens the water, purifies, etc. So this project absolutely nailed it. So from day one, they set out a strategy. That strategy did include a significant proportion of off-site assembly. I think their target was 70%. And by setting out the stall from day one, everybody buying into that delivery method, this is what the guys were able to achieve.
Started with a 3D model, so we're not producing lots and lots of 2D drawings. The model's been shared throughout our supply chain. That's enabled the designs to be developed much quicker in a more collaborative environment.
The original design back in feasibility was to get involved in the existing plant, too risky. We built a completely new plant separately within an existing redundant building. Been with the project from the feasibility stage 4 years ago, now to the design and build stage, and watching the plant develop has been quite amazing really, and the scale of the plant.
I'm most proud of the way that we've been able to work closely with Severn Trent Water, collaboration with them, with the designs, and get their ideas and work with them, kicking around ideas to get things finalised quicker.
We had federated models, so our suppliers inputted into our 3D model. So we had one common platform. This followed through with their design. So it was really about early engagement, greater collaboration, and driving the off-site to then reduce our on-site costs. Frankly, we had a 70% off-site challenge. This started right back last year when we were in the conceptual phase of the project. Before our designers really got into the detail of the design, we held workshops and set out our off-site strategy. And we really formulated the ethos that it will be done off-site unless there's a very good reason not to do it.
To ensure that we got the job right first time for our client, Severn Trent Water, and their operations team, We gave them access to our model and our design from the very beginning of the project via mobile devices. This meant that they could navigate around the model, identify anything they weren't very happy with, communicate those concerns and raise them with us at a timely manner so that when we delivered the scheme, it was right first time.
Right the way through from design through to our supply chain, we've taken this a step further with the 4D planning software, and we've had dozens of sessions with our supply chain in where we digitally rehearse installation sequences, making them a lot safer. We can in the safety of a classroom, we can really thrash out some of the hazards that may be faced on site and deal with those before the guys get to site.
The workshops that we've had with everyone's participated, and it's been a real pleasure, and everyone's come out of those really buzzing. And then we've seen when that's transposed to site, the forward momentum of the installation hasn't faltered. Everything's been calm. There hasn't been a backward step, and it's gone according to plan.
What 4D did was actually make the identification of those benefits far more visible. When you connect the 3D model with the program and you digitally rehearse what you're going to be doing, that really helps the project team get together behind the 4D model and identify where those benefits are going to come from. And we've identified a number of different things through lifting processes, for example, that would have been affected on site had we not digitally rehearsed those processes to start with. So they've really shown the benefit.
It's been a real pleasure to become part of this project. We're hoping to invest a lot more time with verification and collaboration before equipment and assemblies come to site, and go into detail. And the guys have been familiar with collaborative planning and obviously traditional 2D drawings, but using 4D synchro and the animations with the temporary works, that's really brought to life what we're trying to do on site. And you can see with the guys, they sit back and they see this and think, wow, what have we achieved here? It's fantastic.
Okay, so yeah, hopefully that's demonstrated the real benefits when all the digital tools effectively come together. Now, I believe on that scheme there was 6 months that was taken off the original construction program duration, and there was circa £2.5 million cost saving as well that was calculated. So, real huge benefits. So, last slide, guys. The top one there, it just sort of highlights what I've said in the presentation, really, with the fundamental changes of how we deliver projects now. But really, the end result here is what this is all about. It reduces cost, it reduces time, it improves safety, health, environment, and quality. And massively improves stakeholder engagement. So thank you for your time. I think we've got some time now for questions. So Greg, I'll stop presenting now and hand back to you.
Well, hopefully the both of us. Thank you very much, Neil. That was a very interesting presentation and lots of very powerful technology. We've got some questions which I'd like to read out. The first one is from Mike Underhill. And he's asking, how fast is UV treatment of wastewater, and does it have to be slowed down to deal with COVID? A topical question. I'm not sure if it's in your field.
Right, okay. Yeah, that's slightly off piece, that question, but yeah, regarding COVID, I really don't know. I mean, we're not aware of COVID in any of our water treatment processes. I mean, if anywhere, you'd expect to see it on the wastewater side, and I don't believe we've, it's been detected there. But sorry, the question was regarding to the speed of UV, was it?
That's right. I think he's asking, do you have to slow down your flows through your UV filtering systems in order to handle something?
Yeah, so, well, UV needs a contact time with the light, and that's obviously calculated as part of the process design to ensure the flows that pass through the ultraviolet lamps have sufficient contact time. So, and that'll obviously vary for the different processes. And I'm sure if there's any process engineers on the call, they'll be able to give you a rough time, but hopefully that answers the questions best I can anyway.
Okay, next question is from Amy Hindle. Can you use BIM 360 as an automated QA system? Also, can it be used to produce electrical drawings, such as block cable diagrams, or is it only really for civil drawings?
No. So first of all, the quality side of things. So if we look at BIM 360 field, so you can actually manage your quality using the application. Inspection and test plans are generated on the actual tablet themselves. They are stored electronically in a system, so they certainly assist with the whole quality process. Going back to producing electrical single line diagrams, that's more of the packages. So BIM 360 glue and fill, they're not actually drafting tools. There are plenty of other tools out there that do that. I mean, some of the electrical engineers, I mean, the basics, they use Antec. So Antec is a tool for actually not only drawing your single line diagrams, but it works out all your electrical characteristics and sizing as well. So yeah, and Antec's a package that our electrical designers use. But if we're just talking about cable block diagrams, etc., then typically we just run those through our CAD packages.
Okay, thank you. Next one is from Mike Underhill again. How do you digitally transfer lessons learnt from one project to later projects?
Yeah, that's a great question. I think the whole lessons learned across the industry in general is really interesting. So there's not a specific system where we can say that's the tool that we use for lessons learned. I'm sure there are applications out there. I mean, the fact that we're cloud-based now, there's absolutely applications where we can do it. I think it's all about the capturing of the lessons and making sure they're communicated appropriately. So there's not one particular piece of software. I guess if you looked at BIM as a whole, that's part of the process, better information management. And what you would look to do there is what is the best way of communicating those lessons learned. So, and it doesn't have to be a complex system. You know, it can be project-wise, it could be SharePoint or whatever.
Okay, thank you. The next one is from Anna Haywood. During program visualization, can you also visualize the commissioning process and add additional constraints, such as limitations to durations of shutdowns?
Yes, absolutely. So some of the digital rehearsals that we do on some of our sort of larger projects, the commissioning planning now is done using 4D Synchro. So you can actually, you've got your model, you've got all your piping arrangements, you can colour the various routes with the flows as you bring things online. And of course, because it's time related, you can put in constraints as well. So yes, 4D Synchro is used for commissioning planning. Okay.
The next one from Anna Haywood again. Have there been any limitations with the digital delivery approach that you should be aware of? How much training is required by the project team to be able to use the technology, particularly once you move into digital asset management, where site operators may have to use the technology?
Yeah, that's a really good question. So where do I start with that one, really? What we've found, that the introduction of digital, it's emerged out of the engineering team, because typically, you know, we're technical guys, etc. Once you start pushing it outside of the engineering team and you're trying to get it into the operational side, the sites, etc., yes, you do find challenges. Where we've had successes is where we've had younger members of the team on site that are tech savvy, and they just completely embrace it and they can see the value of it straight away. Some of the challenging areas are where you may have guys working on site that have been in the construction business for years, have always done it traditional, and don't want to change. And one of our regional design managers referred to them as digital dinosaurs, jokingly, but that's what you're up against. So yes, implementing on site can be a challenge, and training as well. What we've found, it's good to introduce these tools incrementally and just trial them and test them, rather than go for try and work everything out and do a massive big rollout. So just start introducing, just start giving them a go. That's where we found the benefit. But there are other limitations as well. So I mentioned earlier the laser scanning. They produce huge files, massive files. So you need a plan in place on where they're going to be stored. So simply, you can take the laser scan and have portable hard drives, but that's not ideal. So you do need to be thinking about your IT systems as well. And then, clients, the end users, if you're going to pass this information on successfully and it's going to be used and maintained, your clients need to be up to speed and ready and prepared. And quite a few clients, still in the water industry, are still getting there on that front.
Thank you very much. Okay, so the next one is from Claire Hyde. This has been a great presentation, Neil, demonstrating digital tools used at the right time throughout the project lifecycle. Have you been using any tools for remote inspections, site visits, etc., especially in COVID times?
Yes, we found, so the laser scanning that we've undertaken has been really beneficial for our remote design teams. So we're based down in Brighton on the south coast. We've got design teams in Manchester, and by undertaking the laser scanning, it's really helped with the remote working. One of the scanning techniques that actually I didn't have a slide on that has been used in other regions is a drone that sits within a cage that they've actually sent down really terrible enclosed areas, so sewers and manholes. So as long as it's intrinsically safe, the device, you can send it into a tank that you don't want to send personnel into, and get a complete scan of the inside of the tank.
Great. Well, you're kind of answering the next question, I think, from Philip Benstead. Are drones used to image capture, including photogrammetry?
Yes, yeah. So absolutely. They are used. There's different techniques. You can use laser scanning. I think some of them operate on LiDAR, and there's different levels of accuracy as well. So, it goes back to your application. If you're trying to just get a visual, so if you're doing a long cross-country pipeline, then drone surveys are great, because they provide that visualization. But we are in the framework that I'm in Southern. We work within the boundaries of the site, so more often the work that we do is very detailed and needs to be millimetre accurate because we're interfacing with the existing assets. But yeah, absolutely, drones are used.
Yeah. Okay. Next question from Lorenzo. Have you explored digitalising existing assets, for example, a sewage pumping station?
Yes, yeah. So, I mean, that's effectively creating a digital twin of that asset. So that's from a point of view of having a record digitally. of that asset, we kind of do that now. So when we're scanning stuff, we've got representations of that. I think really the next stage to that is the digital operation, is where that asset has got a true digital twin, and not only the physical asset, but all the operating parameters as well are existed in that twin. And so you can effectively run scenarios of what it might do in certain conditions. So there are examples of that out there, but that's not something we get particularly involved with at this stage.
Sure. Okay, next question from Jonathan Bird. Thanks for a fantastic presentation again. And will the recording be available afterwards? And Jonathan is from Aberdeen Oil and Gas, I think. So I think the answer to that is yes, you've given us permission and we will be making it available afterwards. Okay, the next one is from David James. Your descriptions covered civil and mechanical design and installation. Does your digitization include instrumentation and control?
Yes. So one of the techniques that I didn't have a slide on today was intelligent P&IDs. So process and instrumentation piping diagrams are the Bible in many industrial sectors, certainly in the water industry. So intelligent P&IDs are something that we use treatment as a business in our region. We're not using them in particular, but the benefit of intelligent P&IDs are that you actually generate an electronic version of that, so that if you're producing your piping and instrumentation diagram, it automatically generates the associated schedules with that design. So that's valve schedules, instrument schedules. So so OPID, Open Plant P&ID, is the tool that treatment are using at the moment. I believe Autodesk do a similar type tool. Okay.
Next question is from Volodymyr Kasareski, and apologies for mispronunciation, but congratulations. And is it simple to use the same technology in other sectors of construction, e.g. rail? And how do you see the spread of this technology with time? And will it require upskilling of existing project teams?
Yeah, so I would say there are other sectors that are more advanced in digital than the water sector. So if you just take the commercial buildings, etc., I see that they adopted the whole digital approach earlier. Certainly the main players in commercial buildings, and probably oil and gas as well. I don't know a great deal about oil and gas. Sorry, what was the second part of the question?
I confess I'm not sure, because I move up the list and I deleted it.
Yeah, sorry, I can't remember the second part.
I think it was about upskilling teams and how much.
Yeah, so upskilling teams, absolutely. I mean, it's kind of linked to an earlier question that you do need to do that, and you don't want to underestimate sometimes what you need to do there. But what you've got to remember is it might only be a certain individual in a team that's driving that piece of technology, but it's benefiting the whole wider team, because they're just turning up to, if you like, the collaborative planning session, and they're benefiting from it. So yes, you do need to upskill, but you don't need to upskill everybody.
Yeah. Okay, next one from Jonathan Bird. Do you use the digital twin for competence assessment? For competence assessment.
I understand the question on that
Can't
one.
hear you, Neil.
Sorry, not sure I understand the question on that one.
Do you use the digital twin for competence assessment?
No. I must admit, I'm not really following the question on that one, so apologies. If you want to drop a clarification note out.
Okay, I think the next one is from Joe Lancaster. A standard form for lessons learnt for each project would enable BIM 360 or other systems to create reporting.
Yeah, that's a good point. Very good point.
The next one from Neil Winstanley. When would BIM drawings be used beyond 3D, i.e. 4D, 5D, 6D?
Yeah, so I mean, as you can see on the bin wedge, that's something that we're moving to. I think the natural progression after linking the model to the program is cost. I mean, we've obviously had cost-loaded programs before, but linking all three together. So that's on the horizon, and I'm sure we'll start to see some of that progress in AMP7.
Okay. Next one from Andrew Abdulmasi. After project handover, how can the client add or modify the site to keep the models up to date?
Well, yeah, this is the thing. You've got to have a client that has fully embraced the whole digital aspects, such that he's keeping up to date and maintaining the record. So if you take the example, of a water treatment works, so that you can have multiple projects over a period of time by multiple people. So the client has to have a system where there's one version of the truth, the digital twin, and he's got processes and procedures where any upgrades, changes to that project, first of all, they get an export of that model and they work on that basis, but it goes back again. So really important, and that's where I think a lot of clients are not quite there at the moment.
Okay. Next question is anonymous. What challenges are coming up with digital delivery that we should be inspiring to the next generation after the ones who are already adopting this way of working?
Wow, yeah, that's a good one, really.
Can you come closer to the mic, Neil?
Yeah, sorry. Yeah, it's an interesting question. So, what's next, effectively, for you? Yeah.
Get your crystal ball out.
Yeah, that's right. I'm sure there are many. I think probably it's around the operational side. I mean, I look at what we deliver in the water sector, and it's having that full visibility and that operational control, and predictivity of what's going to happen. Artificial intelligence is a progression as well. That's something that as a business we're looking at. So systems, AI systems that on safety, where you look at any accidents and incidents that happen, you feed into the system. When you then come to review a method statement or a risk assessment for a specific task, instead of that document landing on the site manager's desk, him reviewing it and relying on his level of experience to pick up anything that's wrong or any historical type accidents or incidents around that type of work, the AI system produces a list and almost does a review of that method statement. So yeah, I guess for the future generations, that's where it's at.
Yeah. Okay. The next one from Eric McKinnon. How is the software managed, assuming that it's not bug-free, which we can probably assume?
So, I mean, this is a challenge with technology. Software progression and upgrades all the time. So you do find now and again some incompatibility with systems, but I think that's an area that if you're embarking on the journey, you do need a clear plan. You need to know what your alignment is of the software platforms, and obviously you need to keep up to date with those revisions. Now that doesn't mean every time they issue an upgrade, you've got to upgrade, but at least you need to be aware of it and everybody working on the same platform.
Yeah. Okay, and the last question we have here. Did you find any resistance to the digitization of your projects? If so, how did you overcome the resistance?
So a really good question to finish on. Yes, we did. Yes. So there's a perception, initially, until we started seeing the real benefits, and hopefully they came out in the presentation and the video. There was a perception that it was just something that added cost to a project, something that was a bolt-on that you didn't really need to do. What's the benefit? So it's a journey, really, that you've got to go on. You've got to try this stuff. And there'll be a few failures along the way, but when you get it right, and as you've seen from the videos, you can actually see the real benefit. So it's articulating that to project teams. It's persevering, and it's pushing forward with it as a way forward.
Yeah, okay, and I've got another question, a late one, left field again. Great presentation, Neil. How would I go about getting involved, as I have a similar background to yours?
Right, okay. Well, I don't know if you could share my details, but yeah, be very interested. Yeah.
Okay, fine. Okay, well, that was all the questions. Thank you very much. It was a great presentation, Neil. We really enjoyed it. Very well presented too, I'd like to say. So thank you very much, and thank you for coming.
I'll just say briefly, thank you to a couple of people. So first of all, thank you to Ramon Tumbos for giving me the opportunity to present this evening. So yeah, thanks to Ramon. Thanks to Steve Kennedy, who's the digital and innovation lead for treatment, who helped me out with quite a lot of the material this evening. And lastly, Sean Manley, who's our CAD technical lead, who helped me out with editing some of the videos. So, but no, really good. Enjoyed it. Thanks for your time.
Thank you very much, and I wish you good night, and wish everybody else good night too.
Cheers.